DAX is where people quit Power BI. Not the interface, not loading data. DAX. You learn to drag fields, you make some charts, you feel good. Then you write your first calculate. It returns something insane and you have no idea why. And that's usually where it stops. So here's what we're doing today. 20 functions. That's it. 20. And they genuinely cover about 90% of what real dashboards need. I've grouped them into 5 sets and each set builds on the last. Now this video works differently and I want to explain that before we start. This is not a video you watch. It's a video you do. 7 times I'm going to stop and ask you a question. There'll be a countdown on screen, actual silence, and you have to commit to an answer before I tell you. And I mean actually commit. Say it out loud or type it in the comments. Because here's the thing about DAX. Reading it feels easy. Predicting what it returns is the actual skill. And those are completely different abilities. If you just watch, you'll finish this video feeling like you understand DAX. And you won't. If you do the challenges, you'll get about 7 honest signals about where your gaps are. And don't try to memorize these. Nobody memorizes DAX. You look up syntax forever. And that's normal. What you're building today is the ability to predict behavior. And that you cannot look up. And if you can, open Power BI alongside this. Let's start with the one idea everything else depends on.
Before any functions, one concept. And if you only take one thing from this video, take this. Because every confusing DAX result you will ever get comes back to it. It's called filter context. Here's the idea. A measure is never calculated on your whole table. It's calculated on whatever slice of the table is visible at that moment. And the chart decides what's visible. Let me make that concrete. You write total sales equals sum of the sales amount column. Simple. Now you drop that measure into a card all by itself and it shows 50 lakhs. That's everything. Now you put the same measure in a table broken down by region. South shows 12 lakhs, North shows 15. You did not write 4 different measures. You wrote one, but it got calculated 4 separate times and each time it could only see the rows for that region. That's filter context. The row in your visual creates an invisible filter and your measure runs inside it. So when someone asks, why is my total wrong? The real question is almost always what filters were active when this ran. And there's a second source of filters, the slicers and the filter pane. Those stack on top of the ones your visual creates. When a number looks wrong, listing every active filter is the fastest way to find it. Okay, first challenge, and this one's a warm-up. Same total sales measure. It's in a table sliced by region. Someone clicks south in a slicer. What does the north row show now? Countdown starts now.
It shows nothing. The row disappears because slicing to south removes north from the visual entirely. So there's no north row left to calculate. If you said 0, that's the interesting wrong answer. And it's worth understanding why. 0 would mean the row exists and the value is empty. It doesn't exist. Alright, set 1. The aggregators. 5 functions and these are your bread and butter. Sum of a column, that's your workhorse. Average, same shape, mean instead of total. Count rows, which counts rows in a table. Notice it takes a table, not a column. So count rows of sales give you the number of transactions. Then distinct count of a column for unique values. That's how you count customers rather than orders. And mixing those up is one of the most common reporting errors there is. And fifth, divide. Not technically an aggregator, but you'll use it constantly. It takes a numerator and a denominator and handles divide by 0 gracefully instead of breaking your visual. Never use the slash. One note on distinct count. It's slower because it holds every unique value in memory. On a few million rows, you'll never notice. On 100 million, you will. And the fix is to count a numeric key, not a text column. Right. Challenge 2. You have a sales table. 1 row per order line. So a single order with 3 products is 3 rows. You write count rows of sales and call it total orders. What have you actually counted and what should you have written? Go. You counted order lines, not orders. Your number is inflated, probably by 2 or 3 times, and nothing will warn you. What you wanted was distinct count of the order ID column. This exact mistake ships to production constantly. Now, set 2. Calculate. This is the one. If you properly understand calculate, you understand DAX. And if you don't, you'll be guessing forever. So here it is. Calculate changes the filter context that a calculation runs in. That's it. That's the whole function. First argument, the thing to calculate. Every argument after that, a filter to apply. So south sales equals calculate, total sales, region equals south. And now that measure returns south, always, no matter what row it's sitting on. Put it next to total sales in a table by region, and every row shows the same south number, which looks broken, but it's exactly right. And understanding why is the whole game. Here's the mental model I'd give you. Normally, the chart tells the measure what to see. Calculate lets the measure argue back. And calculate does one more thing nobody tells beginners. Inside a row context, it converts that row into a filter first. That's context transition, and we'll come back to it at the end. Now, challenge 3, and this one separates people. You have total sales, and you write calculate, total sales, region equals south. You put it in a table sliced by region, and you click north in the slicer. What does the south sales column show? Think carefully. Countdown.
It shows the south number, the full south number, because the filter you wrote inside calculate overrides the filter coming from outside. That's the rule, and it surprises everyone the first time. If you said blank or 0, you were thinking of the two filters combining, which is reasonable but wrong for a simple equals filter. Set 3, the filter modifiers. 3 functions that shape what calculate sees. First, filter. You use it when your condition is more complicated than a simple equals. Calculate total sales, filter of sales, sales amount greater than 1000. Filter walks the table row by row and keeps what matches. It's powerful and it's slower, so only reach for it when a plain condition won't do. Second, all, which removes filters. Calculate total sales, all of regions gives the grand total across every region. That's how you build percent of total, your row value divided by the all version. Third, all selected, and this is the subtle one. All selected ignores the filters from the chart itself, but respects what the user picked in slicers. So your percentages are of the visible selection, not the whole dataset. That's usually what people actually want. One warning about all. All of a whole table clears every filter on it, including ones you wanted. If you only meant the region filter, write all of that column, not the table. Challenge 4. Percent of total using all. The user slices to one region. Does each product's percentage change? Yes or no? Go.
Yes, it changes. And people get this wrong constantly. All of regions removes the region filter from the denominator only if the slicer is filtering the regions table. Your numerator still shrinks to the selected region, so the percentages all drop and no longer sum to 100. If you wanted them to keep summing to 100 within the selection, that's exactly what all selected is for. Set 4. The iterators. These are the functions ending in X, and the difference is genuinely simple once someone says it plainly. Sum adds up a column that already exists. SUMX creates a value for each row, then adds those up. So you have quantity and unit price, but no line total. SUMX of sales, quantity times price. It multiplies on each row, then sums. No calculated column needed, and this is the correct way. Average X, same idea. Average instead of sum. Very useful for average order value done properly, where you want the average of each order's total, not the average of every line.
And rank X, which ranks? Rank X of all products by total sales. Notice the all. You almost always need it to rank against everything rather than the row you're on. A performance note. Iterators do work per row, so SUMX over 10 million rows costs more than some. But the engine is fast. Write the correct formula first and optimize only when something is actually slow. Challenge 5. Sum of price times sum of quantity. Is that the same as SUMX of price times quantity? Yes or no, and why? Count down.
No, and they're wildly different. Sum of price times sum of quantity multiplies two grand totals together, which is a meaningless number. Sum X multiplies on each row first, then adds. That's your actual revenue. If you have 10 rows, the first version is basically nonsense and the second is correct. This is the single most valuable thing about understanding iterators. Set 5. Logic and helpers. If, which you already know. If, condition, value if true, value if false. Fine for one condition. Switch for several. And specifically, switch true, which is the pattern you'll actually use. Switch, true, then a list of condition and result pairs. It reads top to bottom, takes the first match, and it's far cleaner than 5 nested ifs. Then, selected value. This returns the single selected value from a column, or blank if there's more than one. It's how you make a dynamic title that says showing south when the user picks south. And finally, not a function but essential. var and return. Declare a variable, use it below. It's faster because it's evaluated once and it's dramatically more readable. Get into this habit early. One more on variables. A variable is evaluated once where you declare it and keeps that value even if the filter context changes later. That trips people up inside calculate, and it's also how you lock a value deliberately. Challenge 6. You write a measure using selected value of region for a title. The user selects 2 regions. What appears? Go. Blank. Selected value only returns something when exactly one value is selected. With 2, it gives you blank, and your title vanishes, which looks like a bug to your stakeholder. The fix is a second argument, a fallback. Selected value, region, and then multiple regions as the default. One extra argument, and it never embarrasses you. Set 6. Time intelligence. 5 functions, and these are why business dashboards get built in this tool. But first, the warning. All of these need a proper date table that you have marked as a date table. If you skip that, they return blank and give you no clue why. Total YTD. Your measure, your date column, and you get year to date. Running total from January 1st, respecting every other filter. Same period last year. Wrap it in calculate, and you get the same window 1 year back. Put this year and last year side by side, and you have a comparison. Date add, which shifts by any interval you name. -1 month, -1 quarter, whatever you need. It's the flexible version. Dates in period for rolling windows. Last 12 months from today, that kind of thing. And previous month, which does exactly what it says. And on fiscal years, since someone always asks. Total YTD takes an optional year-end date. Pass it the 31st of March, and year-to-date matches how your business reports. Challenge 7. You write year-over-year growth as this year minus last year divided by last year, and January shows blank. Why? Count down. Because there's no last year for January in your data,
Your dataset starts in January, so same period last year has nothing to return, and dividing by blank gives blank. It's not a bug, it's correct, and it looks broken to a stakeholder. So you handle it, either with an if that checks or by accepting that the first period is always empty and saying so on the chart. Now let me give you the debugging skills, because you'll need them. First, the one that catches most people, context transition. When you use a measure inside an iterator like SUMX, something happens quietly. The row you're on gets converted into a filter, so the measure sees only that row. That's usually what you want, and when it isn't, it's baffling. Just knowing this has a name and looking it up will save you hours. Second, the variable trick. When a measure gives you a weird number, temporarily change return to output one of your variables instead. You'll see immediately which piece is wrong. Third, build in a table visual, not a card. A card shows you one number and hides the pattern. A table shows every row and the wrong ones stand out. And fourth, the performance analyzer in the view ribbon. It shows how long each visual took. When a page is slow, that finds the guilty visual in 10 seconds. Last challenge, number 8, and it's the most practical one. Your measure works in a card but is wrong in a table by month. What's your first suspicion? Go.
Filter context. Almost always. The card has no filters on it, so the measure sees everything and looks right. The table applies a month filter to every row, and something in your formula is fighting it, usually a stray all or a calculate with a hard-coded date. Start by checking what filters that row is actually applying. So, 20 functions. Let me lay them out one more time. Aggregators, sum, average, count rows, distinct count, divide. The core, calculate, filter, all selected. Iterators, SUMX, AVERAGEX, RANKX. Logic, if, switch, selected value. Time, total YTD, same period last year, date add, dates in period, previous month. And var, return, wrapped around all of it. Here's the order I'd learn them in. Week 1, the aggregators and divide. Get comfortable. Week 2, calculate and nothing else. Over and over until it stops surprising you. Week 3, all and percent of total. Week 4, iterators. Week 5, time intelligence. 5 weeks to genuinely useful DAX. And the real test isn't writing these. It's predicting what they return before you press enter. Tell me in the comments how many of the 8 you got right. If it's fewer than 4, that's the most useful thing you learned today. And one last tip. When you're stuck, stop writing DAX and say the problem in one plain sentence. For each region, the total of last year, ignoring the product filter. That sentence usually tells you the functions. Subscribe if this helped. See you in the next one.